Patients are anaesthetised before surgery. The time in minutes it takes for a patient to return to consciousness after surgery, called the recovery time, is an important measure of the procedure. Let mu be the population mean recovery time. From historical data, the population standard deviation is sigma, which is equal to 25 minutes. A random sample of 100 recovery times is taken of patients who have undergone a tonsillectomy. Let x bar denote the sample mean recovery time. State the approximate distribution for x bar. So first thing to state is that n is greater than 30, and therefore we can use the central limit theorem, and we can say that x bar is a normal. Now we weren't told a mean, so let's just put mu there, but then we do have 25 squared over 100. Now in this particular case, since we're always working with standard deviation on the calculator, I usually state sigma x bar is going to be 25 over 10, which is 2.5. And in this particular instance, they actually gave a mark for that. Determine the probability that the sample mean is greater than the population mean by more than 3 minutes. Now we don't actually know the population mean, so we could do this using a z-score. So z is going to be x take away mu over sigma, and we're talking about more than 3 minutes, which would be mu plus 3. So it's going to be mu plus 3 take away mu divided by 2.5, which is 3 over 2.5. So what we're doing is the probability of z being more than 3 over 2.5, which is the probability of z being more than 1.2, which you can do on the calculator and get 0.1151 to 4 decimal places. But just note, you could have done this by just choosing your own mean to work with. You didn't need to use a z-score. So if I go into normal CDF here, what I could do is say my lower is 103 and put my mean as 100. So I'm just choosing the mean score to be 100. The standard deviation here is 2.5, and we were trying to find, so the upper was infinity and we were trying to find the probability. So put the upper as infinity, and let's just get rid of that, and then solve. And you see it gives the same answer. So you could just choose your own mean rather than using the standardized score. Okay, let's move on to the next part. If it is required that the sample mean have a 50% chance of being within m minutes of the population mean, determine the value of m correct to 0.1 minutes. So once again, you could do this by just choosing your own mean, like 100, and then going between 103 and 97. That would work perfectly well. And basically we want it being but 0.5 in there, so half of that would be 0.25. And so all the way back down there would be 0.75. So what we could do is, if we use the z-score again, do the probability of z being less than m over 2.5, which is just the same thing as how we did the 3 over 2.5 up here, and put that equal to 0.75. That would give us the m over 2.5 is 0.67448. It's just an inverse norm. Multiply both sides by 2.5 and we get that it's 1.7 minutes to 1 decimal place. And again, you could just choose your own mean and you would get the same sort of result. A particular sample of size 100 produces x bar is equal to 15 minutes. Calculate a 99% confidence interval I for the population mean recovery time. This is I1 because it's going to refer to I2 a bit further down in the question. Well, we know how to do these. You can do them on the calculator. It's only 2 marks, so there's nothing to stop you doing that. If we do the calculation, it's going to be, we've just been told the mean is 15. Take away the Z score for 99, which is 2.5758, times the 2.5, which we know is the standard deviation. That's going to be less than mu, is less than 15 plus, this time, the 2.5758 times 2.5. And that would give us the interval 8.56 to 21.44. A new procedure for tonsillectomy using an assisting robot was trialled. A random sample of 400 recovery times was taken for patients who underwent the new procedure. The observed sample mean was 14.5 minutes. The 99% confidence interval, I2, for the population mean recovery time for the new procedure was found to be between 11.28 and 17.72. 2 junior doctors made the following statements. Probably should have done more maths at school. Angio. The new procedure is superior as its sample mean of 14.5 minutes from 400 patients is lower than the sample mean of 15 minutes from 100 patients, and by using a larger sample size we can be more confident. So what do we think about angio? False. And basically you cannot make an inference just based on 2 specific means. We know that there's variation in samples. Sanjeet, since the interval I2 lies completely within the interval I1, then it can be inferred that the population recovery time for the new procedure is the same as that for the old procedure. Sorry, Sanjeet, that is also false. We're comparing, or what he's doing is comparing confidence intervals based on different sample sizes. Lost the ability to write for a moment. Different sample sizes. So that doesn't work either. Calculate the minimum sample size required to estimate the mean recovery time for the new procedure with an interval width of at most 4 minutes using a 95% confidence level. So we have an E activity that does that. It's this one here, sample N for CI. We can see the formula there is N is equal to Z sigma over E all squared, and I've already done the 95% confidence 1.95996. That's already there. I did that using the Z score for CI. Just put in 0.95 and solve, and it gives you that one, and it automatically puts it in here. We know our sigma was 25 from the beginning of the question. E is 2 because it's saying the width of the interval is 4 minutes, and that means that our E is equal to 2. Substitute all those values in and solve, and you can see we get 600.227. So it's going to be 600.227. We know this is the sort of situation where you always round up. So N is 601.